You know that note on your fridge or the data on your computer's hard drive? They're all held in place by this fundamental force that's completely, totally invisible. We're talking about magnetism. And while you can't see it, our modern world would literally fall apart without it.
So what is this invisible force that runs your world? Well, the answer is all around you, pulling and pushing in ways that make everything from your headphones to high-speed trains possible. And in the next few minutes, we're going to make it visible. So here's our game plan. First up, we'll get to the bottom of what this invisible force actually is. Then, we'll dive into the simple rules that every single magnet has to follow. After that, we'll see how you can actually map out a magnetic field. We'll sort out the difference between permanent and temporary magnets. And finally, we'll see how it all comes together to power the world you live in. Okay, let's start with the big question. We know this force is invisible, right? But what's really going on? What is it that makes a material magnetic in the first place?
It all comes down to something called the magnetic field. And no, this isn't science fiction, it's a real-world force field. Think of it like an invisible bubble of influence that surrounds any magnet, just waiting to pull or push on anything magnetic that comes near.
But here's the catch. This force is pretty picky. It doesn't affect everything. Actually, only a handful of materials are magnetic. The big three are iron, nickel, and cobalt. A good way to remember that is I-Nico. Oh, and steel is magnetic too, but that's just because it's mostly iron. But what about something like aluminum or wood or plastic? Nope, they just don't have the right stuff inside to feel the force, so the magnetic field completely ignores them.
All right, so now that we know what it affects, let's look at how it behaves. It turns out there are a few simple, unbreakable rules that control every single magnetic interaction in the universe.
Okay, so every magnet has two distinct ends, a north pole and a south pole. This is where the magnetic force is packed in super tight. It's where it's strongest. And this force can reach out across space. It's a non-contact force. You've felt this yourself if you've ever played with two magnets and felt them pull or push before they even touch.
And that brings us to the golden rule, the one everybody knows. Opposites attract and likes repel. Bring a north pole near a south pole and they'll snap together. But try to push two north poles together or two south poles, you're going to feel that invisible wall pushing back as they repel each other.
So if this magnetic field is really invisible, how in the world can we study it? How do we know what shape it has? Well, it turns out there's a surprisingly simple way to map it out, and you guessed it, make the invisible visible.
You can actually do this with a tiny little plotting compass. Here's how it works. You put the compass near the magnet, and you just make a little dot where the needle points. Then you move the compass so its base is at that dot, and you mark the new spot. You just keep doing this over and over, and when you connect all those dots, poof, the hidden pattern of the magnetic field appears right there on the paper.
And those lines you've just drawn, they tell a story. They follow three key rules. First, they always flow out of the North Pole and into the South Pole. Second, they can never, ever cross each other. And maybe most important, the closer together the lines are, the stronger the magnetic field is. You can see how they're all bunched up right at the poles, and that's exactly where the force is the strongest. Okay, now we need to make a really important distinction, because it turns out not all magnetism is the same. There are actually two different types, permanent and induced.
A permanent magnet, like your fridge magnet, is the real deal. It creates its own magnetic field all the time. It's just always on. You can't switch it off. But an induced magnet, well, it's more like a temporary copycat. Think of a paperclip. It only becomes a magnet when you bring it into the magnetic field of a permanent magnet. The moment you take that permanent magnet away, poof, the paperclip goes back to being just a plain old paperclip. And here is the absolute key takeaway. Induced magnetism can only cause attraction. That paperclip will always be pulled towards a magnet, never ever pushed away. And that means repulsion is the ultimate test. If you see one object pushing another one away, you know with 100% certainty that you are looking at two permanent magnets.
So why does all this matter? I mean, poles, fields, induced magnets, who cares? Well, in this last part, let's connect all these ideas back to the real world and see how this invisible force is quite literally powering your life.
Seriously, magnetism is everywhere. The sound coming out of your headphones, that's tiny magnets vibrating. Those super-fast maglev trains, they literally float on a cushion of magnetic repulsion. Your credit card stores data on that little magnetic strip. On a bigger scale, scrapyard cranes use giant electromagnets to lift entire cars. And get this,
Planet Earth itself is a giant magnet, with its hot molten iron core creating a massive magnetic field that protects all of us from nasty solar radiation.
So we'll end on this thought. We've taken a force that is completely invisible to our eyes, and we've learned not only how to see its shape, but how to use its power to build our entire modern world. It really makes you wonder, what other hidden forces are out there, all around us, just waiting for science to give us a way to see them?